After finding what is P and Q, the next step is to find out integral factor. How to find integral factor of this form? Then it is equal to e to the power integral of P into dx. What does our integration by parts says? So it says first function, I'll take first function as log here. Remember the rule LIATE, logarithmic first and then algebraic and then exponential. Integral of e power y is e power y. Derivative of y is 1. Again integral of e power y is e power y. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So last session we have studied about the homogeneous differential equation, and in today's session we will learn about the linear differential equation and solving linear differential equations. So let's see what is linear differential equation. So a differential equation expressed in the form of dy by dx plus P into y is equal to q, where P and Q are constant or they must be the functions of x. Then these type of differential equations is called as linear differential equation. See here, you can see the order of this differential equation is 1 and the degree of this differential equation is also 1. That is why it is also called as first order linear differential equation. So hence, if you have any differential equation and it can be expressed in the form of dy by dx plus p into y is equal to q. So this is what the linear differential equation is. Now, what is the method of solving this linear differential equation? So the very first thing is, whenever the differential equation is given, express it in the form of dy by dx is equal to p into y plus q. So find the integration factor. IF is equal to E integral of P into dx. So here integral factor is necessary to find the solution. That is always integral of P into dx. Where this P comes, P is from the given equation. It may be a constant or it may be a function of x. And after once you got the integrate factors, then write the solution of the given differential equation in the form y into integral factor is equal to q into integral factor dx. So here f represents the integral factor. The solution has to be written in the form of y into integral factor is equal to integral of q into integral factor with respect to dx plus c. So this means if we have dx here, all the functions are expressed in the variable of x here. Suppose if our differential equation is of the form dx by dy, then the equation should be expressed in the form of dx by dy plus px is equal to q. So the other differential equation what we have discussed is dy by dx plus p into y, we have to write p into y is equal to q. So this is type 1 and this is another type 2 you can take. So it is dx by dy p into x is equal to q. So there p and q, that means here p and q are the functions of x. Here they are the functions of x again, and you can integrate it by using integrate factor here. So here integral factor can be e into integral p into dy. That means you are integrating the exponential function with the variables of y only. That is why we have written dy there. And again the solution of these type of equation has to be written as x into integral factor, q into integral factor, integrate with respect to dy. Well, about this solution we take y into integral factor, integral of q into integral factor with respect to dx we take plus integration constant. So these are the things you have to remember. So first express in the form of any one of the linear differential equation, then find the integral factor, then write the form of solution and solve it. Find the general solution for the differential equation. So here we are going to find only the general solution. Whenever the value of x and y are given, we can also find the particular solution for these linear differential equation also. So finding the general solution or solving the linear differential equation is for 5 marks in your examination, which is very important. So you will get one question from linear differential equation to solve for 5 marks in your examination. So let's look at the first problem. X log x dy by dx plus y is equal to 2 by x log x. We need to express it in the form of dy by dx plus py is equal to q, or dx by dy plus px is equal to q. So now I have dy by dx. I will divide throughout by x log x. So what happens? Then it is dy by dx plus y divided by x log x is equal to, you have 2 by x here, log x by x log x. So here you can see log x cancels. So we get here dy by dx plus 1 by x log x into y is equal to 2 by x. Now this is of the form dy by dx plus p into y is equal to q. So comparing these two equations, here what is p? We get here p is equal to 1 by x log x and q is equal to 2 divided by x. So when you have converted it into the linear differential equation form, then we can write the constants p and q. But here p and q are the functions of x. Now what is the next step? After finding what is p and q, the next step is to find out integral factor. How to find integral factor of this form? Then it is equal to e to the power integral of p into dx. So what is p here? It is 1 over x log x dx. So we already know log x is f of x, 1 by x is f dash of x. So whenever the integral is in the form of f dash of x by f of x, it can be written as log x. Therefore, this can be written as log of log x. So here it becomes e to the power log of log x. So whenever exponential function power is in terms of log, e power log x can be written as x. So therefore, e power log of log x can be written as log x. So therefore, my integration factor here is log x. So once you got the integral factor, then you have to write the solution in the form y into integral factor is equal to integral of q into integral factor with respect to x plus integration constant. So what is my integral factor? It is log x. So therefore it is y log x integral of, what is q I got? 2 by x log x with respect to dx plus c. Now I have to integrate two functions here. So when you are integrating two functions at the same time, use integration by parts. So therefore here also remember the rule L, I, A, T, E. So this is how first logarithmic, inverse, then algebraic, trigonometric and exponential functions here. So using that rule, I can apply the integration by parts here. So first, let me take the first function as log x and second function as 2 by x. So here it is y log x is equal to first function log x into integral of second function 2 by x dx minus integral of second function and derivative of the first function, that is log x. So again with respect to dx plus c. So now I have y log x. So 2 is constant. I can write it as it is here. So 2 into, so here it is log x outside. Integral of 1 by dx is again log x. So next I have minus integral of 1 by x here. 2 I can take it outside or I can write there only 2 by x. And here log x is 1 by x. So with respect to dx plus c. 2 I can take it outside. So here y log x is equal to, so let us write this in the form of dy by dx. If I need dy by dx here, I should divide whole equation by x log x. When you divide it, it becomes y divided by x log x is equal to 2 by x here log x, and here we have x log x. Log x cancels, this becomes 2 by x square. Now compare this equation with the original equation, that is dy by dx is equal to or plus py is equal to q. Now here comparing these two, we get p is equal to 1 over x log x and q is equal to 2 divided by x square. Now once you got value of p and q, you are supposed to find the integral factor, which is e to the power integral of p into dx. So what is p here? E to the power 1 over x log x dx. Integral of 1 over x log x can be written as e to the power log of log x. Now e to the power log can be cancelled and you can just write it as log x. So therefore my integral factor is log x. So once you got the integral factor, you can write the solution in the form of y into integral factor is equal to q into integral factor with respect to dx. You are going to integrate plus c, integration constant. So log x is the integral factor, just write it. So integral of q is 2 by x square log x with respect to dx plus c. Now I will take 2 outside, it is 1 by x square into log x plus c. So clearly we have two functions to integrate here. So I need to write dx, two functions to integrate here. So I will apply integration by parts. What does our integration by parts says? So it says first function, I will take first function as log here. Remember the rule LIATE, logarithmic first and then algebraic and then exponential. So therefore log x and integral of 1 by x square dx. Again minus integral of 1 by x square dx into derivative of log x. So again we have to integrate this with respect to dx plus c. So this is 2 for log x, not for the integration constant. Now here we have 2 log x. Integral of 1 by x square is minus 1 by x. And here minus integral of 1 by x square is minus 1 by x. Again 1 by x we have. So with respect to dx plus c. Next here we have, so 2 into minus log x by x. And here we have minus 1 by x square whose integral is again 1 by x plus c. So therefore when you multiply 2 inside, y into log x is equal to, you can take it as minus 2 by x log x. And again you can write minus 2 by x, or you can take minus 2 by x outside. Then you will get log x plus 1 plus c. So this is the solution for the linear differential equation given. Next, dy by dx plus y secant x is equal to tan x. This is already in the standard form. So therefore here the value of p is equal to secant x and q is equal to tan x. So let me find the integral factor, which is e to the power of p into dx. So which is e to the power of secant x dx. We know that secant x is e to the power log of modulus secant x plus tan x. So therefore e power log, when you have, you can write the value directly. So this is secant x plus tan x. So therefore my integration factor is now secant x plus tan x. Use the solution, y into integral factor, integral of q into integral factor with respect to x plus c. Substituting here we have y into secant x plus tan x, Q is tan x here. So tan x into secant x plus tan x with respect to dx plus c. Multiply this, you will get secant x tan x plus tan square x. Outside we have dx plus c. We don't have standard integral for tan square x. So therefore I will take it as secant x tan square x as secant square x minus 1. Outside we have dx plus c. Now I can write this as secant x plus tan x into y is equal to. So first, integral of secant x tan x is secant x plus integral of secant square x is tan x minus integral of 1 is x plus c. So this is the solution for the given differential equation. Next we have x into dy by dx plus 2y is equal to x square. Divide the equation by x, then this becomes dy by dx plus 2 by x into y is equal to x. Clearly you can see this is the standard form. So therefore p is equal to 2 by x and q is equal to x. Now find the integral factor. Integral factor is e to the power integral p into dx, which is e to the power 2 by x dx. So 1 by x is log x. So this becomes e power 2 log x. Or I can write it as e power log x square. Log and exponential can be removed and you just directly write x square. So therefore my integral factor is x square. Now the solution is y into integral factor, integral of q into integral factor with respect to dx plus c. My integral factor is x square, so this becomes x square into y. Here q is x into integral factor is x square with respect to dx plus c. Integrating this, we will get x square into y, x cube is x power 4 by 4 plus c. Or rearrange these things, then it will become 4x square y is equal to x power 4 plus c. So this is the solution of this differential equation. Cos square x dy by dx plus y is equal to tan x. So divide the equation by cos square x, then this becomes dy by dx plus y by cos square x is equal to tan x. 1 by cos square x can be written as secant square x. So this is secant square x into y is equal to tan x. So next here we have p is equal to secant square x, q is equal to tan x. Find integral factor, which is e to the power integral of p dx, which is secant square x dx. Integral of secant square is tan x. So therefore integral factor is e power tan x. Now my solution is y into integral factor, q into integral factor integrating with respect to dx plus c. So therefore this becomes y into e power tan x is equal to q is tan x. So tan x into e power tan x dx plus c. So here we have cos square x dy by dx plus y is equal to tan x. So here to write the equation in the form of dy by dx, divide throughout by cos square x. Then this is dy by dx plus y by cos square x is equal to tan x by cos square x. This can be written as dy by dx plus secant square x into y, and here you can write it as secant square x into tan x. Now find the integral factor. So to find the integral factor, e to the exponential power, that is p into dx. What is p here? It is secant square x. and integral of secant square x is tan x. So therefore it is e to the power tan x, and hence my integral factor is e power tan x. Now applying the solution as y into integral factor, integral of q into integral factor with respect to dx plus c. So what is y? An integral factor is e power tan x. So we have q as secant square x tan x, and integral factor is e to the power tan x with respect to dx plus c. So now here put t is equal to tan x. So if you put t is equal to tan x, just take this integral, that is integral of t into e power t dt. So because I have taken t as tan x, then dt is secant square x. So secant square x dx becomes dt. This is t into e power t. Now apply integration by parts. So first function, integral of secant minus integral of secant with respect to dt. Derivative of first is 1, and here we have plus integration constant. So therefore here this becomes t e power t minus e power t. So now in the place of secant square x tan x e power tan x, I can replace the value of this with t e power t e power t. What is t we have taken? We have taken t as tan x e power tan x minus e power tan x plus integration constant, and here we have y into e power tan x. So this is the solution for the given differential equation. Next, x into dy by dx plus 2y is equal to x square log x. So then dividing throughout by x, we get dy by dx plus 2y by x is equal to x log x. X and x get cancels. So now integration factor is equal to e to the power p dx. So what is p here? It is 2 by x. So 2 by x dx, which becomes e to the power log x square. We can be written as x square. And then y into integral factor, that is x square, is equal to integral of q x log x into x square dx plus c. Now x square y is equal to, this becomes log x into x cube with respect to dx plus c. Now integrate it. First function, integral of x cube becomes x to the power 4 by 4 minus integral of x to the power 3 becomes x to the power 4 by 4. Derivative of log x becomes 1 by x with respect to dx plus c. So here again x get cancels. So we have x square y, and here we have x power 4 by 4 log x minus, again we have x cube, outside we have 1 by 4. So 1 by 4 x to the power 4 by 4, and we have integration constant plus c. So here you have x square y is equal to, you can take x power of by 4 as common factor, then it is log x minus 1 by 4 plus c. So this is the solution of the differential equation. Next question, we have x plus 3y square dy by dx is equal to y. So divide y, then what happens? X by y plus 3y, and dy by dx I will shift there, then it becomes dx by dy. Now this is the equation of the second type, dx by dy plus x by y, and here 3y we have, so we can write it as minus 3y. And here this can be arranged as dx by dy minus x by y is equal to 3y. This can be compared with the equation dx by dy plus px is equal to q. So when it is of the form dx by dy px is equal to q, then integration factor will be equal to e to the power integral p dy, and solution will be in the form of x into integral factor and here q into integral factor with respect to dy plus c. So remember, this is what we have to apply the solution. Now here what is the value of p? P is minus 1 by y. And what is the value of q? It is 3y. Let me find integral factor. Integral factor is e to the power integral of p into dy. And I can write it as minus 1 by y dy, which can be written as e to the power minus log y. And log y is nothing but e to the power log of 1 by y. So thus I will get 1 by y is the integral factor. Now let me apply the solution. X into integral factor is equal to integral of q into integral factor with respect to dy plus c. Now here I have x by y is equal to integral. What is q? Q is 3y. So 3y into 1 by y and here dy plus c, y get cancels. So x by y, integral of 3 becomes 3y plus c, multiply y on both sides, it is 3y square plus cy. So this is the required solution. Next, y into dx plus x minus y e power y dy. So here divide throughout by y dy. So y dy. Then what happens? Y get cancelled. This becomes dx by dy. Plus here it becomes dy get cancels. The first one becomes x by y and the second one is minus e to the power y is equal to 0. Or I can write dx by dy plus x by y is equal to e to the power y. Now again this is of the second type, that is dx by dy. So therefore what is p here? It is 1 by y. What is q here? It is e to the power y. And integral factor for 1 by y becomes log e to the power log y, which can be written as y. So therefore my integral factor is y now. Now solution is x into integral factor is equal to integral of q into integral factor with respect to dy plus c. So integral factor is, I got here is y. So therefore this is xy is equal to, so this is e power y into y dy plus c. Apply integration by parts. Take algebraic function because exponential function has to be integrated at last. So first function, integral of e power y is e power y only plus integral of e power y is e power y. Derivative of y is 1. Again integral of e power y is e power y plus c. This is the solution for this differential equation. Next one, x plus y dy by dx. I'll just put dy by dx, then this becomes dx by dy. X plus y I have, I'll take minus x here is equal to y. Now here p is equal to minus 1, q is equal to y. Now integral factor is e to the power integral minus 1 dy. So this becomes e to the power minus y is the integral factor. Now my solution is x into integral factor, q into integral factor with respect to dy plus c. Now we have x into e power minus y, q is y here, y into e power minus y with respect to dy plus c we have. So now integrated separately, x into e power minus y. So here we have first function, integral of e power minus y is minus e power minus y. Minus again integral of e power minus is minus e power minus y. And derivative of y is 1 with respect to dy plus c. Now here we have x into e power minus y is equal to, here we have minus y e power minus y. Now again here integral of minus e power 5 is again minus e power minus y, which becomes positive. Now so therefore it is minus e power minus y plus c. So here multiply both sides by e power y. E power minus y, what happens? It get cancelled, it becomes exponential power with 0. So therefore it is x, and here it is minus y, and here it is minus 1 plus c into e power y, or shift this towards left hand side, then this is x plus y plus 1 is equal to c into e power y. Thus, this is the required solution for the linear differential equation. Hence, linear differential equation can be expressed in the form of two types. One is dy by dx is plus py is equal to q, or dx by dy plus px is equal to q. For the first function, p and q are functions of x. For the second one, p and q are functions of y. So, find integral factor and apply the solution and solve it. You will get the solutions for the differential equation. As I said, there will be one question from linear differential equation for 5 marks in your examination. So, this completes the chapter differential equation. We'll meet you in the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.